All right, as we get started, I want to quickly review some things with you because we've got a speed drill coming up here in just a few moments. And it's been a little while since we've done anything with area. I think in the financial literacy supplement, we have one set of exercises dealing with area. But this first figure class, this is called a triangle. How would we find the area of a triangle? Kirsten, do you remember?
BH?
Well, we wouldn't just multiply the base times the height, Jalen.
A equals 1/2.
Right, 1/2 BH. We basically showed that let's come over here. Let's come down to the rectangle. This is actually the first one we talked about. And for the area of a rectangle, let's go back to Kirsten. What was that formula?
LW.
A equals LW. And you realize instead of length and width, if we wanted to, we could call this the base, couldn't we? And we could call this the height. What about a parallelogram? How did we find the area of a parallelogram, Elaine?
A equals BH.
A equals BH. And we basically showed if you were to cut the parallelogram along the height, you could pick the piece up, put it right here, and you'd have the rectangle with the same size base and height. So really we said a parallelogram is just a distorted rectangle, but it's still really kind of the same formula. Well, a triangle rather is half. Right? So that's why it was the half BH. Do you remember that now? What about the square? Kind of a different formula for the area of a square. Luciana?
A equals S squared.
A equals S squared. We would take one side and square because if you think about it, this is like the base, this is like the height, but it's the same all the way around, so we just said side squared. What about the trapezoid? This was a really unusual one. Corey?
A equals 1/2 H times the quantity of B1 plus B2.
There we go. We'd have to actually add the two bases together and take half the height times that sum of those two bases. And then the circle. What was the formula for the area of a circle, Bryce? Just put the water bottle on the floor.
A equals pi squared.
Not pi squared, but you're close, Griffin.
A equals pi r squared.
Pi r squared. We have to square the radius of the circle first and then multiply that by pi. And so those were our area formulas. Just want to quickly refresh your memory on those. Something else we've looked at earlier this year is this idea of squaring something. We know that whenever you square something, class, you multiply it by itself. So if we saw something like 2/5 squared, we know that means 2/5 class times 2/5. Well, when you multiply fractions, you multiply 2 times 2, 4, and 5 times 5. Or you realize what you could do, if we're lazy, is just square the 2 to get 4 and square the 5 to get 25. Let's do that with the 1/6. Let's square the 1 class. 1 times 1 is 1. And then let's square the 6. 36, because 6 times 6 is 36. What about 3/4 squared, Joel? What would we get if we squared a 3/4?
9/16.
9/16, right? What about decimals? Well, ignore the decimal. Don't think of this as 1.2 squared, class. Think of it as 12 squared. What's 12 squared? 144, right? 12 times 12. Now, how many decimals do we see, class?
1.
But technically, if I multiply it by itself, there'd be another 1, wouldn't there? So how many total decimal places? 2 decimal places. 1.44. So here, don't think of this as 0.03 squared, class. Think of it as simply 3 squared, or 9. Now, how many decimal places do we see? 2, but then there's going to be another 2 when we multiply by itself. How many total decimal places? 4. 1, 2, 3, 4. We end up with 0.0009. So with this 2.3 squared, well, don't think of it as 2.3 squared. Let's think of it as, well, that's not one we've memorized. So let's multiply the 23 by itself. And at this point, if you're going to multiply it by itself, you could go ahead and put the decimals back in. Or just remember in your answer, class, how many decimal places? 2 decimal places in the answer. And 3 times 3, class? 3 times 2? We put a 0. 2 times 3?
6.
And 2 times 2?
4.
9 plus nothing?
1.
6 plus 6?
12.
Carry the 1. 1 plus 4?
5.
And of course, we've got our 2 decimal places in there, and there's our 5.29. Questions on squaring, especially when it's weird stuff like decimals or fractions. Do we see how it's really not that bad? All right, let's go ahead then. Have your desk cleared of everything except for a pencil and a pen, which we'll use in just a little bit. And let's take our next speed drill. Did want to do a little bit of that review with you. Open up your speed drill booklets to our next speed drill. which is speed drill 43. Speed drill 43. In your speed drill booklets, speed drill 43, they're at the top of page 21. And you'll have 2.5 minutes to complete this speed drill. So top of page 21, and you may begin. Don't sit there and be lazy. Do your best. Don't buy things by themselves. Stop. All right, pencils down, pencils off your desk, in fact, and have on a pen. Exchange with the person behind you, person in the back. Bring yours to the front. Exchange with the person behind you, person at the back. Bring yours to the front. All right, looks like we're all good now. Sign your name as grader, if you would, next to where it says speed test 44. They're at the bottom of speed drill 43. Sign your name as grader at the bottom of speed test 43, right next to where it says speed test 44. And these are 10 points each. Going across the top row, should have filled in the first blank with LW. LW. For the next one, should have put S squared. S squared. For number 3, you should have had 1/2 BH. 1/2 BH. And for number 4, should have had 1/2 H, and then in parentheses, B1 plus B2. 1/2 H times the quantity, B sub 1 plus B sub 2. Yes, sir?
Why did they put 4S, S4?
No, that's not the same thing. S squared and 4S. 4S is the perimeter, S squared is the area. Yeah. All right, bottom row going across. 11 squared, we should all have this memorized. It's 121. 34 squared, we had to work that one out. Should have gotten 1,156. 1,156. Number 7 should look vaguely familiar. 5.29. So for those with really good memories, you could have kind of cheated the system there. 5.29. Number 8, that one should look familiar too. 9/16. 9/16. Pays to pay attention, doesn't it? Number 9, okay, we had to work that one out. 1.1236. 1.1236. And number 10 should have been 62,500. 62,500. All right, they're 10 points each. Figure the score, put it in the score blank, and then also, if you would please, on the main score page, put it next to where it says Speed Drill 43. So put the score next to where it says Speed Drill 43. Once you got the score both places, pass it forward to the person in front of you. Person in the front, take it to the back. Person in the front, take it to the back. And let's take a look at our scores here. Some confusion here in the middle row. And any hundreds today? Any hundreds? It's a tall ask. Okay, we did have one. How about 90s? Just missed one. Not shabby. 80s, still pretty solid. Okay, got a few of those. Questions? Questions? All right, pass those forward if you would please. As a reminder, all of these, about 10 or so speed drills we'll do this quarter will average together for one quiz grade. Once you pass those forward, turn in your books to page 285. Turn in your textbooks to page 285. So pass them forward, be opening up your textbooks. Your homework was to do numbers 12 through 22 on page 285. Homework was to do numbers 12 to 22 here on page 285. Let's take a look at these together. You don't happen to have like a homework pass left over from the old days, do you, Corey? No. Alright, page 285, thanks, sir. We're looking for a mode. Okay, so that's we're looking for the number that occurs most often. Let's quickly review some things before we take a look at this homework together. We've been talking about the study of data. What is the branch of mathematics that collects and studies data? Statistics, very good. And as we study statistics, we said that with a group of numerical data or statistics, we want to find what's normal. Or really in any set of data, we want to find what's normal. And so we have three measures of center that tell us what is normal. The first one we talked about is the actual arithmetic average of a group of numbers. What's the term for the arithmetic average, Kirsten? The mean. We also said we could put the data in order. Well, if you put the data in order numerically, that's called doing what to the data? If we put it in order numerically. Michael? Ranking the data. It's like putting basketball teams in order from best to worst, right? Ranking the teams, or ranking the data from least to greatest. And once we put the data in order from least to greatest, we can kind of salt and pepper the numbers off the ends until we get to one central value. What do we call that middle value of a ranked set of data? Median. And what if there's two numbers in the middle? What if they don't salt and pepper their way to one value? What if they salt and pepper their way to two values there in the middle, Elaine?
You add them, divide them by 2, and there's
there we go. Average those two middle numbers. Find the mean of the two middles to get your median. And then the last one we talked about on Friday is beneficial to us in that we can use this even if there aren't numbers involved. Like you can't average colors. You can't average favorite vacation destinations, right? You can't average that, but you can find what occurs most often. And what is that term for a value or a data point that occurs most often? Class? The mode. Okay, class. What was the mode? Most often. So when we think mode, we need to think two words, class? Most often. When we think mean, we need to think average. When we think median, we need to think middle. And when we think mode, we need to think most often. There we go. All right. By the way, there was another term, and that was kind of to tell us how spread out the data is. We want to find the difference between the smallest value and the biggest value. What's that difference between biggest and smallest? Luciana? The range of the data. Now on number 12, they gave us a rather interesting little, it's not really a graph, but it kind of is a graph. It's called a dot plot, where basically they went to the local kennel and they made a dot plot of all the animals that were there. So any reptiles they saw, they would just put a little dot. And anytime they saw a dog, they put a dot. Anytime they saw a cat, they put a little dot. And clearly, what is the mode? What is the type of animal that is in the kennel most often? Or what do they have most of at the kennel for number 12? Ben?
Cat.
Cat, because there's more dots for cat. It definitely stands out. Then a flea market rented out booths, small booths, medium booths, large booths. And they made a dot for all the booth sizes that they had rented out to vendors. And what's the mode of the data on this one here, Bryson?
No mode.
No mode. They're all the same. Honestly, if even two of them were the same, not necessarily a mode. Could there be two modes? Yeah, if two things really rise above everything else. But other than that, no, we just say no mode. Now, on numbers 14 through 19, we didn't do this in class because we were pressed for time. But I said the best way to find the mode is to go ahead and rank the data. So on number 14, Michael, I want you to tell me how we would rank that data set.
12,
There's a smaller number than 12. 9.
12, 13, 17, 18, 19.
And there we go. Now, again, ranking the data allows us to easily see class the range is 10. We can also salt and pepper our way to two middle values, but since they're the same, we know the median class is 17. They wanted to know the mode, and it was also really easy because there was one number that stood out among the rest, class. 17 clearly stood out among the rest. How many had 17 as your mode? Number 15, how would I rank the data here, Griffin?
14, 18, 24, 24, 27,
I got a 25 first, then a 27.
27, 33, 36.
There we go. By the way, strategy tip, if you leave a gap between your numbers as you write them, if you were to write 27 and realize, oh, there's a 25, you'd have room to insert the 25. All right, so we've got our data ranked. Was there one number that stood out, class?
No.
There's two numbers, but do they really stand out? No, if there were maybe a couple more 18s and a couple more 24s in here, then maybe I would say this is bimodal. There's two modes, but I mean, there's really not one number that stands out. So our answer for number 15 should be what, Griffin?
No mode.
No mode. And most of you could probably see this without ranking the data. But again, if you rank the data, it makes it easier to see the mode. It also makes it easier to see the range here. Anyone is? What's the range? 22, right? Difference between highest and lowest. And we could also salt and pepper. I'm going to cross off 4 and cross off 4. And then 24 is our median value. So again, you can do a lot when you rank the data. It's a powerful tool to help you analyze the data set. For number 16, hey, they ranked it for you. Wasn't that nice of them? What's the mode in number 16? Bryson?
No mode.
87, there's two of, and there's two 65s, but again, no one number that stands out. What about number 17? Once again, they were kind enough to rank the data for us. And what's the mode here, Corey? There's like two of almost everything. Nothing stands out on number 17. It's kind of like, you know how some public schools, like everybody makes the honor roll? Like every kid's an honor student. Okay, if every kid's on the honor roll, does it even mean anything anymore?
No.
I'm on the honor roll. You are? Yeah, you don't even know what the capital of our state is. Oh, well, I'm on the honor roll. I don't know. It's like it's meaningless. So anyway, there's two of that. It doesn't mean anything at this point. Number 18, they didn't rank the data for you. Oh, well. What mode stood out to you on number 18, Luciana?
No mode.
Once again, no mode. There's a pair of 101s, but there's also a pair of 89s, so whatever. There's a lot of boring no modes. That's 4 in a row. Number 19. What you got for the mode there, Elaine? 10. Yeah, 10 stood out on the list number 19. How many had 10 as the mode there? Questions on mean, median, mode, ranking, range, all those terms we've been looking at lately. All right, look at number 20 and read that for us if you would, Jalen.
12 classrooms participated in the school candy sale. 5 classes sold 150 boxes each. 3 classes sold 175 boxes each. 2 classes sold 215 boxes each. 1 class sold 110 boxes. And 1 class sold 117 boxes. Find the mode. Does the mode agree with the median or mean or median?
Now that last question is really the kicker, because up till this, it's a super easy problem. Which number happened most often, class? 150, because 5 different classes sold 150 boxes. That's more than any of the others. The next was 3 classes sold 175. So like 150 stands out as the the mode. How many, first of all, had the mode as the 150? That part should have been easy. But then it asks you, does the mode agree with the mean or the median? You know what that means we have to do? We got to find the mean and the median. Now here's what we're not going to do. Let me tell you what we're not going to do. What we're not going to do is write out 5 150s, 3 175s, 2 215s, a 110 and a 117, and then add them all together. We're not going to do that. Instead, what we're going to do is we're going to multiply 5 times the 150 to get anybody? Do it quickly.
750.
750. Okay, so that's those ones. Then we're also going to multiply the 175 times 3. Someone find that, call it out for us. 525, good. And then we're going to multiply the 215 by 2. Call that one out when you got it. 430, good. And then we've also got a 110 and a 117. And we're going to add these numbers. But once we add them up, what do we have to divide them by, class? 12, because there's 12 classes, right? And so we add this all together and we... Okay, good. I've got as far as the 32. Yes, 1932. It's a good year. Just kidding. I wasn't alive back then. And then we're going to divide that by 12. 12 goes into 19, class? Once with 7 left. How many times does 12 go into 73?
8, 9,
Nine.
7,
6. 6 times 12 is 72. There's 1 left over. How many times 12 go into 12?
1.
We got that one at least. Okay. So 161 is the mean, right? The mode, we said, is 150. And then what about the median? Well, for this, we'd have to put them in order, wouldn't we? We'd have the 110, the 117, and then we'd have 5 150s in a row. And then, that's why I did 5 150s. Then we'll have a trio of 175s. And finally, we'll end with a pair of 215s. Well, what's in the middle, class? A whole bunch of 150s, right? I mean, technically there's cross off a few, salt, pepper, salt. I missed somebody. Oh, I missed a 175. Okay, there we go. Salt. There we go. That's salt, pepper, and there's a pair of 150s in the middle. There we go. And so the median is also 150. So the question asked, does the mode agree with the mean or the median, class? It agrees with the median. How many got that second step correct as well? All right, questions on number 20. Yes, sir.
Wouldn't it just be easier to just like find the median first, and then if it wasn't the median, wouldn't it?
But what if it agreed with both? Yeah, could have been a trick question. What if it agreed with neither? You see? So yeah, it's trying to be tricky. Number 21. Read that for us now, if you would, Kirsten.
The high temperatures for the past week were as follows: 53 degrees Fahrenheit, 49 degrees Fahrenheit, 51 degrees Fahrenheit, 57 degrees Fahrenheit, 48 degrees Fahrenheit, 49 degrees Fahrenheit, and 56 degrees Fahrenheit. Find the mode. Is the mode closer to the mean or the median?
All right, so we got a whole bunch of stuff there. What number stood out to you as you read it, Kirsten?
49.
Barely, but it did kind of stand out, didn't it? So I only had 49 degrees Fahrenheit as your mode. 49 degrees Fahrenheit is the mode. It's the only value that repeated itself. It's not much repetition, but it technically is the only one. So the mode, we know, is going to be 49 degrees Fahrenheit. Then I kind of like Michael's strategy at least. So let's at least get an idea of what we're doing and save the hardest thing for last, right? The median seems like it'd be easier. So if we rank the data, we got a 48, 49, 49, 51, 53, 56, 57, 1, 2, 3, 4, 5, 6, 7 days. What is the middle value here, class?
51.
That's a very poorly written 51, but it does say 51. So our median is 51. Does the mode agree with the median, class?
Yeah.
No.
No, but it's not too far off. So let's now find the mean. And the mean is kind of mean to us because we have to actually add everything together. And, oh goodness gracious. Somebody got 363? Anyone else finds 363 to be the sum of all of them? I'm getting some nods, so I'm just going to take your word for it. And we'll divide the 363 by 7. Class 7 goes into 36. 5 times with 1 left over. 7 goes into 13. Almost 2 times. Almost twice. I'm going to say that the mean is approximately 52 degrees Fahrenheit. Okay? We're just going to be a little bit lazy. Because, I mean, if that was just one more, it would have been exactly 52. What's the mode closer to, class?
Median.
Median. So it's closer to the median, and that's our other answer for number 21. Already got both parts of 21 correct. Questions on 21? Number 22, we come back to Ben. Go ahead and read this for us.
Janet makes bracelets, necklaces, and earrings using her signature design. Each signature piece can be made using silver, gold, or
Pewter.
pewter. The main feature of each piece can be turquoise, quartz, glass, or resin. How many different signature pieces can Janet make?
All right. And what do we have to do here, Ben?
Multiply
What do we have to multiply?
the 3 different pieces.
The 3 different types of jewelry. Good. So we got either bracelets, necklaces, earrings, like 3 different types of jewelry times
The 3 different types of whatever.
metal, right? Silver, gold, pewter, those are all metals. So we multiply the 3 metals, and then we also multiply
4
stone type things, the accent pieces here. And we multiply it all out, we get how many different signature pieces she makes?
144.
Ooh, 3 times 3 times 4. We have a little bit too much cooked in there. Michael?
36.
Should be 36, right? 3 times 3, 9 times 4, 36 different signature pieces. How many at 36? Your answer on 22. All right, flip back to page 283, if you would, please. Flip back to page 283. And take a look at word problem number 16. Read this for us now, if you would, Joel.
The top winners in 7th grade reading contest read 7,283 pages, 7,165 pages, 6,840 pages, 5,102 pages, and 5,000 pages. Find the median number of pages. By how much does the median differ from the mean?
Now there's obviously no mode here because all the people read different numbers of pages. But how would we find, first of all, it says the median number of pages? Class, just find the middle value, right? After they're ranked, to use the term that Michael just used. But notice, because they listed the winners from top to bottom, they sort of inverse ranked it. Do you see that that's just as good ranking high to low as low to high? It still helps us out. So clearly, what is the median number of pages here, Joel?
I did do it.
Well, no, we're doing it now. Like right now. Like look at the 5 numbers they gave you and tell me what the middle one is.
Oh, 6,940.
There we go. 6,840 pages is the median. Now for the hard part. How far off of the mean is the median? What are we going to have to do, class? Add those numbers together, divide by?
2.
Careful. 5. Add them and divide by 5. So do that at your seats very quickly. And then they want to know, obviously these two numbers aren't the same, right? The median and the mean are not the exact same number. They're not too far off, right? They're pretty close. How far apart are they? By how much do they differ? What do I need to do in my final step now, class? Just subtract. The median minus the mean. And Kirsten's got it?
638, right?
Ooh, oh, careful. You're trying to subtract both ways, it looks like. Okay, so we want to make sure we're subtracting this, so we're going to have to borrow and do some subtraction that way. Joel's got it? Go ahead.
572.
Oh, little borrowing issue. Really close. Michael?
562.
562, yeah. When we borrow here, the 13 minus 7 gives us 562 page difference between the mean and median. And honestly, when the numbers themselves are in the thousands, that means they're pretty close, which means both of them pretty good measures of center if we're looking for, if you want to be a top 5 student in a reading contest at this particular school, that's how many pages you need to read in that reading contest period. All right, number 17. Go and read that for us if you would, Bryson.
High temperature for the past weeks were as follows: 3 degrees Fahrenheit, 9 degrees Fahrenheit, 1 degree Fahrenheit, 7 degrees Fahrenheit, 8 degrees Fahrenheit, 9 degrees Fahrenheit, and 6 degrees Fahrenheit. Find the median temperature. Do the mean and the median differ by the whole degree.
Those are awful temperatures, and those are the highs. That poor guy, he's got ice on his mustache, he's got ice in his cup, he went to get a drink of water and it froze instantly. That's a bad day. Anyway, yeah, I don't know where he's living, but I'm glad we don't live there. I mean, I would like snow every now and then, but and I don't like the heat of summer here, but those just sound awful for high temperatures. Can you imagine what the low temperatures are like? All right, so it says find the median temperature. Before we can find the median, class, what do we need to do with the data? Rank it. At your seats, rank and find the median. And Bryson, what is our median temperature, median high for this particular very cold region? 7 degrees Fahrenheit. How many had that for the median high temperature? Class, I didn't ask this. What's the mode that week?
9.
Barely. One could argue no mode, but I would say 9 degrees Fahrenheit is the mode. It does stand out. Not much, but it does stand out. So then all we need to do is find the mean. At least there's small numbers this time. So at your seats, quickly find the mean temperature. I'm going to cheat and use a fraction. Do we get 6 and a 7 degrees Fahrenheit mean? Just add them up, get 43. Divide by the 7, comes to 6 and a 7. So the question was, are the mean and median different by a whole degree?
No.
Not quite. They're different by 6/7 of a degree, actually, but not quite by a whole degree. So really, either of these would be good. Notice we don't have any numbers that are like insanely high. Like for instance, if instead of 9 degrees on the last day, it had then jumped all the way up to 20 degrees. Oh, it's a heat wave. Okay, 20 degrees Fahrenheit. Well, do we see that number is way higher than all the other ones? And I mean, 1 degree is the smallest, but like it's only 2 degree different from that, which is only 3 degree. Like they're still kind of close until that number. What would we call a number like this, class?
Outlier.
An outlier, a number that just is so far off. And which of these 3 measures of center, measures of normal, should we use if there's an outlier, class?
Median.
The median, because remember the median just salt and peppers the outliers right off the list. So if there's outliers, the median's what we want. But in this instance, there really aren't any outliers. What's probably the best indicator of normal? The mean is the best indicator of normal if there aren't any outliers present. Flip over to page 284. Flip over to page 284. And look at problem 28 and read that for us if you would, Luciana.
Mr. Burrows owns a ladies' shoe store. Find below for the following shoe sizes that were sold one day: 7, 10, 6, 9, 7, 7, 8, 9, 8, 8, 7, 7, 8, 9, 6, 7, 7, 8, 7, 8, 10, 8, 7, 6, 6, 7, and...
All right, that's a lot of numbers, right? So a lot of ladies bought shoes that day. What's the mode? What number, as she was reading them? Now, there were lots of numbers repeated, but was there one number that stood out the most, class?
7.
7. 7 stood out the most. And so that's clearly the mode. Why, Luciana, do you think it'd be really helpful for Mr. Burrows to know the mode of the sizes sold?
So we can know like the average shoe size and like, I don't know, get like the materials he needs to make them.
Well, I doubt he makes the shoes. I mean, it's possible, but I doubt he makes the shoes. He probably orders them from other manufacturers, and he sells them there as a store. So he buys them wholesale and sells them at retail. But thinking of that line of thought, not so much so he can make the right sizes, but so he can,
Average it?
Bryson,
Because if you knew like how much people buy like the size of shoes, you could like know like these are the shoes that many people get, so you could like put like the prices on.
okay, I mean, that's possible. You could be like, well, size 7's selling like hotcakes. I'm going to raise the price a couple bucks on size 7. So probably not, though. Usual fair pricing laws keep people from, overcharging on something like that. But at the very least, Michael,
Because so we can know like what shoe size most customers come in with.
so that way he can
Order the right
order more of them when he buys them, right? He wants to have plenty of size 7s on hand. It's like when I order your PE uniforms. Do I have extra large and large? I do, because there are Bens and there are Brysons and there are Griffins. There are bigger, taller people, but most of you are not their size, right? So most of what I order are the smalls and the mediums, and then we've got, Elaine, and so a few others in the class of unknown identity who we maybe need some youth large sizes for, right? Okay, but most of what I order are the smalls and mediums. I order more of those because most people fit into that range. I don't want a whole lot of extra larges and larges when junior hires just don't usually come that size. So, though there are some, right, and that's fine. We want to make sure we have for them as well. But yeah, just a smart business. You want to know what's normal, and that's how this could help practically. Daniel isn't a bad bowler. Not a great bowler either, but not a bad bowler. And read about Daniel and his bowling here on number 29, Corey.
Daniel had these scores for 4 games that he bowled: 110, 100, 125, and 101. Find the median. Why is there no mode?
All right, well, let's answer the last question, or answer the last question first. Why is there no mode, Corey?
Because there's not double.
Yeah, he never rolled the same score twice. That's your seats. Find the mean, find the median. Find the mean and find the median. Crashing next door. I don't know what's going on next door, but there is some loud crashing for sure. Did you add them all together to get 436? Should have been a real hard addition. It's a pretty easy addition. Then divide by 4 came out evenly to 109. How many had 109 for your mean? And there's not a big list, so there's only one salt and pepper, and then boom, you're already to the middle 2 values. Had to add those to get 211, divide by 2 to get 105 and a half. How many got 105 and a half for your median? All right. Are there any outliers on this list?
Yeah.
The 125 is bigger by a decent little bit. I don't know what to call it a total outlier, but it's pushing it. It's on the edge of being considered an outlier for sure. Again, I think either of these are pretty close together anyway. I think if you wanted to say what's his normal score, I think either 105 and a half or 105 or 109 would be a fair thing to say. Questions on this one here? How many got both answers correct? Got them both right. Any questions? Flip over to page 290. Flip over to page 290. And look at the review section at problem number 20. Problem number 20. I've never seen Olivia spelled this way before, but here we go. Since Olivia joined the chess club, she's won 11 games. The following are the number of moves it took her to win each game. Any chess players in here? Chess players, just a couple of chess players, okay? Anyway, I was in the chess club when I was in school. That means I'm a nerd, okay? That's basically what it means. I was the biggest nerd because I was also the president of the chess club my senior year. So, yes, you know, uber nerd. I know, I tell you. You never would have guessed the fact that I'm a math teacher would make you. All right, anyway. So anyway, she won a couple of games in 4 moves. She won a game in 3 moves. That's a hard one to do. Part of me wonders if that's realistic. Anyway, and so we see all these different numbers. At your seats, I want you to find all 3, the mean, the median, and the mode. Number 20. Find the mean, the median, and the mode for how many moves it takes Olivia to win a game of chess. At least in the games that she does win. It doesn't tell us how many she lost because, let's face it, who wants to think about that? That's no fun. Once you got your numbers ranked, make sure there's 11 of them. Count and make sure. You have 11 data numbers written down. If not, figure out which one you missed. If you have 12, you wrote one too many times. And we added them all together to get 81. Divided by 11, and I just left the fraction. 7 and 4 11s. I mean, she's not going to win in a 4 11s move anyway. So anywhere from 7 to 8 moves is considered normal. No outliers, right? So I think the mean 7 to 8 moves sounds about right. Though her median was also class 8, and her mode was also 8. So pretty much Olivia expects to win in 8 moves, which is really good. Again, I don't know how realistic that entirely is. You're going to be doing some of these for homework tonight. We're going to be finding mean, median, and mode. But for now, if you would, flip back to page 286. Page 286. And if I were to give you a choice of candy, and I said you could either choose Starburst, Snickers, Skittles, or Whoppers.
Huh?
They're little malted milk balls. Okay, so how many of you, Starburst, Snickers, Skittles, Whoppers, how many would want the Starburst? Okay, how many would want the Snickers? How many want the Skittles? How many want the Whoppers? All right, so technically, if we were to just put 4 things there, blindfold you, and the first one you touched is what you picked, there's a 1 to 4 chance of you getting Whoppers, let's say. But if you're given the choice, let's be real, class, most of you are going for the Skittles, right? That's what most of you are going for. There's a difference between what we call theoretical probability, which is there's 4 kinds of candy. What's the odds of picking Skittles? 1 to 4. No, there's not. Not if you actually get to pick. If you actually get to pick, there's a much higher odds that you pick the Skittles based on the quick survey that I did in this class, right? This is called experimental probability. For instance, if Griffin steps up to the plate in softball, well, we could say there's a 1 to 2 chance he gets a hit. Either he does or he doesn't, right? Well, let's be real. It's not really a 1 to 2 chance, is it? His odds are maybe, he would like to say, a little higher than that. Say, I get hits more often than that, right? Okay, so in golfing, right, the odds of getting a hole in one. Well, I mean, you could argue it's a 1 to 2 chance, right? Either you do or you don't. No, it's not that way. Some of you actually golf. Like, the odds are extremely low based on what we've actually observed from golfers. The statistics are really crazy low on that, right? Based on what's actually happened. That's what we call experimental probability. Theoretical probability, what in theory should happen, but experimental probability is based on past history. We sometimes call it relative frequency. Relative to the data we've collected, how frequently does something happen? For instance, technically, if, let's see, and I don't think there's any moms in here who are having another baby, but let's just suppose, my wife is not expecting, but let's just suppose my wife is expecting another baby, and we said, I wonder what day of the week the baby will be born on. And we said, well, there's a 1 to 7 chance of any given day, right? Well, no, actually. If we look here, they've done some research, and let's suppose, based on statistics, you see the different days of the week that births take place. Notice which day most births happen, class. Thursday has the highest likelihood of having a baby. The lowest likelihood is on Sunday. Now, that might be because doctors try to induce and try to get the baby out earlier because they don't want to work on Sunday. I don't know. But anyway, we look at those probabilities. It's not exactly even across the board, is it? Because of past history that's been observed. So if you wanted to actually know the probability of a baby being born on a weekend, well, that's Saturday or Sunday. Or means, class? Add. So you can add those numbers together, and what is that? 24.2% of being born on a Saturday or Sunday. What about the probability of not being born on a Wednesday? Well, what's the probability of actually being born on a Wednesday, class?
14.
So how do you think would be the fastest way to find the probability of not being born on a Wednesday? Subtract from 100%, right? That would get you the 85.2%. But these are called relative frequencies, where numbers have actually been categorized. Right? Pitchers use this in baseball. Baseball season just opened up. My Cardinals are off to a very mediocre start. We're 5-5. It's sad. Not as sad as the Marlins, though they did beat us in our last game, but they've only won 1 game so far. But anyway, pitchers use this, right? If there's a really good batter and he gets hits all the time, maybe we want to pitch around him and get the next guy instead. Go after him, like, well, we'll walk him. He's going to get on base anyway, keep him from doing real damage, and maybe we'll attack the next batter, right? So there's strategy used in experimental probability all the time. We have what's called a relative frequency table. It looks a lot like a frequency table, but if you look at the next page, the frequency table, this a lady named Arsene Wenger apparently coaches Arsenal. It's a soccer group team in England, and in the last 1,000 games, they won 572. They had drew or tied 235 games and lost 193. 193 losses really isn't that bad out of 1,000 games played. But anyway, well, 572 out of 1,000 is a 57.2% win rate. 572 tells how many wins. 0.572 on the next table tells you how frequently they win. That's the probability of a win. Does that make sense? So for instance, if we made a table of Starburst and Snickers and Skittles and Whoppers, we would also need to know the total number of people to select each one. So let's see the hands again for Starburst. Any Starburst people? Nobody in this room, given these choices, would choose Starburst. How about Snickers people? Snickers people? We got 1. I'm surprised that number isn't higher, to be honest. Skittles people? We got 1, 2, 3, 4, 5, 6, 7 Skittles people. And Whoppers. We had 2 Whoppers people, for a total of 10 students in the class. This is a frequency table. It just shows how many people actually picked this. Relative frequency shows the probability of a particular student. Let's assume that y'all were a normal group of people. I know. Try to contain yourself, Houston. But let's just suppose normal. Well, a relative frequency table would show the probabilities. So what's the probability of a person picking Starburst, class? 0%. Nobody wants the Starburst. What's about the probability of Snickers, class? 1 out of 10 is what? 10%. or 0.1? What's the probability of Skittles? 70%. 7 out of 10 people. Again, this is assuming you're a normal group of people. And Whoppers? 20%. Now, notice what everything has to add up to on a relative frequency table. It better add up to 100%. Or, if you were doing decimals like I did, stay with me, we'd have 0, 0.1, 0.7, 0.2, in which case it would have to add up to 1. Because the sum of all probabilities has to add up to 1. Does that make sense? So we're going to be working on these tomorrow. Frequency versus relative frequency. But relative frequency is just another way of saying probability based on actual data. Right? So, for instance, a girl has a choice of earrings, necklace, or bracelet. Well, you'd say, well, there's a 1 to 3 chance she chooses whatever. Well, not if the girls routinely, they love their earrings, and they aren't necessarily bracelet people or necklace people. I'd say the odds are probably higher. Ladies, will defer to you here. We say earrings over the other two is more normal, or you disagree? Well, what do you cast your vote? Bracelet, earrings, necklace?
I usually wear earrings, but I'm not wearing any, so I'm gonna go with this.
She's going to go with bracelet because she's not wearing earrings today.
Yeah.
Earrings? You can only pick one. Stop messing with the data. Necklace. Bracelet. Okay, so we got 2 bracelets, we got an earrings, we got a necklace. Okay, so again, there's a mixture there, but again, the odds aren't necessarily 1 to 3, is the point we're making. We'll work on that more tomorrow. For homework this evening, did you do page 290? Page 290. Do the review 18, 19, 21, and 22. And on page 291, do the homework 1 through 5. Page 291, do the homework 1 through 5. You're going to have to find some answers for that. Page 290, review 18, 19, 21, 22. And on page 291, do the homework 1 through 5. All right, you are dismissed. Have a wonderful rest of your day.